So let's look at part 4. Show that when theta is the optimal angle, tangent KDA. So KDA is here. You're looking at this tangent here. Is the value there. So what I'll suggest is actually just write down what is KDA. So KDA opposite this angle here. KDA is this angle here. So we need its opposite, which is x, and the adjacent, which is 4 plus a, right? So we're going to write this down. Okay, so this part 4. Tangent KDA is equals to opposite, which is x, over, maybe I just write this down as x, KA, AK over AD, which is actually AK, which is x over plus 4. So at optimal point, okay, we know that x is equals to, we just take the square root 4a plus a square root 4a plus a square. Then what we're going to do is actually tangent KDA would then be angle KDA. Okay, so this would be 4 a square a plus 4. Okay, so we need to actually just there you go. This is a plus 4. This is a plus 4. So we need to essentially find the square root of this. So one of the neat trick that you could do is actually just square and just square root. Okay, so then this square root, we just use the formula where this is square root p over q is equals to, maybe, no, sorry, square root p over square root q is equal to just square root p over q. Okay, so this is easier. So just square root in and out of this. This would then be a plus 4 over a plus 4 square. Great. So once this is done, we'll get this as a plus 4. There you go. That is shown. Now this is a good thing because this question showing at the end, you can be very sure that your previous answers are all correct because they are all anchored based on the last the previous parts. Okay, so I think this is a pretty good question here. So find the approximate value of KDA when a is much greater. So when a is much greater than 4, okay, it just means that a tends to infinity. So when a tends to infinity, a over a plus 4 will just becomes 1. Am I right? So okay, maybe I should just multiply this with 1 over a here, 1 over a. This is or you can just do long division. So anyway, this would just be 1 over 1 plus 4 over a. So when a goes to infinity, 4 over a. We've done this many times in class, so just make sure you know where you're looking for this information here. So 4 over a goes to 0. So this case here will just be 1. Okay, so when as a goes to infinity, okay, maybe I just, this is 4 over a, tangent KDA. So let me just write this down. This is as a goes to infinity, tangent KDA goes to limit a over a plus 4. This can change this expression 1 over 1 plus 4a. We know that this will become 0. This will be 1. This will be 1. Okay, so hence tangent KDA tangent inverse 1, which is actually pi over 4. Okay, 45 degrees. So are we surprised that 45 degrees should be the optimal angle? I think not, because if you look at this graph here, the optimal angle, you should be able to find a 45 degrees as you move along this point here. Okay, your point as you adjust. So it will increase and then it will decrease after a while. Okay, so that is how you do that there.